Good morning, students. Yes, students. In the continuation with video lectures on motion in a plane, we are at part 15 of the video lecture, and in this video, we will discuss about centripetal acceleration. But before that, I want to recap you about the previous video, that is part 14. In that video, we had discussed about the circular motion. After that, we had discussed about the terms related to the circular motion. In the terms related to the circular motion, we had discussed about angular displacement, angular velocity, angular acceleration, and some relations we have derived, that is v is equal to omega r, f is equal to 1 upon t. Now, I want to tell you that in circular motion, in this chapter, we will discuss only about the statics of circular motion. Means we need not to discuss about the forces which are acting or which are compelling a body to get in the circular motion. We will discuss only about the statics of circular motion. The dynamics of the circular motion we will study about in the next chapter, that is work, energy and power. So let us start our discussion on centripetal acceleration. Today we will discuss only one topic, that is centripetal acceleration, and we will derive the expression for the centripetal acceleration here. So now let us start the topic, that is centripetal acceleration. Centripetal acceleration. Centripetal acceleration. Dear students, it is a type of acceleration. It is a type of acceleration. Type of acceleration responsible to make a body move in a circular path. Dear students, if a body is moving in a straight line, the acceleration is along this direction, and the body is going to be accelerated in this direction, and the motion of the body is a straight line. But what about a body is moving in a circular motion? What about a body is moving in a circular motion? Suppose this is point O and the body is moving along this circular path with velocity v. With this velocity v means velocity is changing. It means that certain force is responsible for the change in velocity, because without force, and in which direction the force is acting, in the same direction there is the acceleration. Means if the force is, suppose you had given a stone and you had tied that stone with the rope, and after that you had started moving the rope in a circular path, means you are giving a force in this way, in this direction. If force is this direction, the velocity is going to be changes in this direction, and the acceleration is along the center. So acceleration is towards the center, and this acceleration which is acting towards the center, A is denoted by AC, acceleration acting towards center, that is called as centripetal acceleration. So we will derive the expression for centripetal acceleration mathematically. First of all, I want to define about the centripetal acceleration. Let us define the centripetal acceleration. Look at here. acceleration associated with uniform circular motion is called centripetal acceleration associated. We are talking about uniform circular motion. Uniform circular motion means the body is moving in a circular track with uniform speed or constant speed. For this, to derive this, consider a particle of mass m. Consider a particle of mass small m moving with constant velocity v, moving with constant velocity v with uniform angular velocity omega, uniform angular velocity omega, on a circular path of radius r. Omega on a circular path of radius, small r, circular path of radius small r and center O. So let us draw the diagram based on this thing. Path of radius r and center radius r and center O. So we have to draw the diagram. This is the circular path which is followed by the object, and this is center O. This is OA, and suppose this point is P, and the velocity is given as PA, velocity in this direction, tangential direction. Now this is point Q and velocity is in this direction. This velocity is supposed as V1 and this velocity is supposed as V2, and this is QB. This is R1 and this radius is R2. This angle is delta theta. This angle is delta theta. So consider a particle of mass m. Particle we had considered moving with constant velocity v. Speed is same, speed constant. You can say that constant speed here, constant speed. Speed is same, but since the direction is changing, so velocity is changing. With uniform angular velocity omega, rate of change of del theta upon del t, that is omega, on a circular path of radius r, and the center of the circular path is O. So this is about the circular path. Now look at the derivation section. look at the derivation section. Suppose at any time t, at time t, the particle is at p, the particle is at p, and OP vector is equal to R1 vector. OP vector is equal to R1 vector. Now, time t plus delta t, at time t plus delta t, the particle is at position q. After traveling at time t, the particle is at point p, and after traveling delta t time, the particle becomes at point q. That is t plus delta t. Delta t, we had increased the time delta t, and the particle reaches on the circular track after covering an arc pq. The particle reaches at point q, where its velocity is vt due to change in direction, and the velocity vector is represented by qb. So at point q, where OQ vector is equal to R2 vector, and angle POQ is equal to delta theta. This angle swept in the time interval t plus t and t plus delta t. The angle which is swept or arc which is made of that arc makes an angle delta theta at the center. But we know that magnitude of R2 vector is equal to magnitude of R1 vector, and this is equal to R. This is radius. Now, angular speed of the particle. So, angular, I think these things are clear to you. These are just introductory part of this circular motion. So, angular speed of the particle angular speed of the particle, which is denoted by omega, is del theta upon del t. This is angular speed. Now, dear students, particle is moving with uniform speed. As the particle is moving with uniform, since the particle is moving with uniform speed, and that uniform speed is v. So, since particle is moving with uniform speed, then length of tangent at P, and the PA and PB are the length of tangents. So, length of tangent means magnitude of these velocities. Simply length of tangents at point P and Q are equal. Length of tangents at point P and Q are equal, and it means to say that is magnitude of PA vector is equal to magnitude of QB vector is equal to V. What is the meaning of saying this? What is the meaning of saying length of tangent at point P? These PA vector and QB vector are representing the velocity vector. And if we are going to take the magnitude of the velocity vector, then it gives the speed. And since again and again I am telling the body is moving with uniform speed throughout the circular track, so the length of tangents, that is PA and QB, is equal to V. Now these two vectors are velocity vectors, and when we are shifting these two vectors, parallel shifting of these two vectors at point P dash, so what will happen? This is the V vector, V1 vector, and this is the V2 vector. And this point is A dash and this point is B dash. And this is the A dash B dash vector. This is obtained by parallel shifting of PA vector, parallel shifting of PA vector and QB vector. Parallel shifting of PA vector and QB vector, as we had told, we had studied in while discussing vectors that parallel shifting of vector does not change the vector. So if we had shifted PA vector at P dash A dash and QB vector as P dash B dash, then the vectors are not changed, and here we had obtained a triangle P dash A dash B dash, and now we can apply here the triangle law of vector addition. So from triangle law of vector addition, now dear students, applying here triangle law of vector addition. So from triangle law of vector addition, from triangle law of vector addition, we can write it as P dash A dash vector plus A dash B dash vector is equal to P dash B dash vector, P dash B dash vector, from triangle law of vector addition. And from here we can calculate vector A dash B dash is equal to P dash B dash vector minus P dash A dash vector, P dash B dash vector, and this is the difference of two velocities, that is V2 minus V1. So del V vector change in del V2 vector minus V1 vector, V2 vector minus V1 vector, and this is the change in velocity, that is del V vector. Now if we suppose that delta t tends to 0, if delta t tends to 0, means t and t plus delta t, here time was for t and here time was t plus delta t, then I am saying that if delta t is tends to 0, means delta t is very small, when the time interval is very small, then in that case what will happen? That case the vector A and B, means these 2 points are very close to each other, P and Q is very close to each other, and if P and Q is very close to each other, then the separation between A and B, then this difference A dash B dash is very small. Then A dash is very close to A dash is very close to B dash. And if A dash is very close to B dash, then A dash B dash can be taken as A dash B dash can be considered as an arc of can be considered as an arc of the circle. And P dash A dash, it can be considered as an arc of the circle, and if it is considered as an arc of the circle, then P dash A dash and P dash B dash is the radius of the circle. P dash A dash is equal to radius of circle. P dash A dash become the radius of the circle, and this become the arc of the circle. And magnitude of P dash A dash is equal to velocity magnitude of velocity vector. Magnitude of velocity vector. Now, if they are sustaining an angle del theta here, so we can write it as del theta angle is equal to, you had studied in lower classes, angle is equal to arc upon radius. So angle subtended what? Del theta, and arc is what? Arc is A dash B dash, and radius is P dash A dash. And it can be written as del V vector upon magnitude of V vector. But from angular speed, we know that for angular speed, del theta we had derived in the previous discussion omega delta t. Since omega is equal to del theta upon del t, we had discussed about this thing. So here we can replace del theta by omega into del t. So we can write it as omega into del t is equal to magnitude del v vector upon v vector, and we can write it as omega v vector is equal to del v upon del t. Now del v upon del t is equal to omega, and v is equal to omega r. We are knowing that v is equal to omega r we had derived in the previous, and from here we can write it as magnitude del v vector upon del t is equal to omega square r. We had considered that delta t tends to 0. So if delta t tends to 0, if this value delta t tends to 0, then del v vector upon del t represents the magnitude of magnitude of centripetal acceleration, magnitude of centripetal acceleration at point P, magnitude of centripetal acceleration at point P. It represents the magnitude of centripetal acceleration at point P, and this can be written as magnitude of centripetal acceleration is equal to del V upon del T. As you are knowing that del V upon del T is acceleration, it is well known to you, and if delta tends to 0, then it becomes instantaneous acceleration. So we had to write it down, instantaneous acceleration, and it is equal to omega square r. Now from here, from this expression, look at, from this expression we can write it omega is equal to V upon r. Omega is equal to put here AC is equal to V upon r whole square into r. And now we are in the position to find out the centripetal acceleration, that is AC is equal to V square upon r. AC is equal to V square upon r. V square upon r. And suppose this is the circular motion, body is subtending a circular motion, body is performing a circular motion. So this acceleration AC and velocity is changing in this direction, and AC is towards the center. So centripetal acceleration, direction of centripetal acceleration, it is towards the center of the circle. It is towards the center of the circle. It is towards the center of the circle. So dear students, this is all about the centripetal acceleration. We have derived the expression. If you have to calculate the centripetal force, then you have to multiply A, then it becomes MAC or MV square upon R. That is the centripetal force, and it is also towards the direction of the acceleration. So we had discussed all about the centripetal acceleration, derivation, how it can be generated, what is the application of centripetal acceleration, how it is responsible for a body to move, to make a body to move in a circular track. All these things we had discussed in the today's video. Now in the next video we will discuss certain 2 or 3 numericals based on the circular motion, and after that we will start our next chapter, that is chapter 5, that is laws of motion. So that's all for today's video, students. Thank you. Have a nice day. Take care.